Hello everyone, welcome to this video of simple repair work and assembly of machine parts from blueprints. Maintenance of machine involves regular servicing of equipment, routine checks, repair work, and replacement of worn or non-functional parts. In this video, we will understand the basic maintenance concepts like total productive maintenance, autonomous maintenance, and identification of defects in a lathe tailstock.
Total Productive Maintenance or TPM aims to maximize overall equipment effectiveness, establishes a complete system of productive maintenance for the machine's or equipment's entire lifespan, is implemented by various departments: engineering, operations, maintenance, quality, and administration. TPM can be considered as the medical science of machines. TPM involves every single employee from top management to all the operators on the shop floor. TPM raises and implements productive maintenance based on autonomous small group activities. TPM is a maintenance program which involves a newly defined concept for maintaining plant and equipment. The goal of TPM is to an extent increase production while at the same time increasing employee morale and job satisfaction. TPM brings maintenance into focus as a necessary and vitally important part of the business. It is no longer regarded as a non-profit activity. Regular maintenance will minimize downtime of the machines and maximize production. The goal of TPM is to stop the emergency and unscheduled maintenance. Form different teams to reduce defects and self-maintenance. Advantages of TPM: avoids wastage in quickly changing economic environment, produces goods without reducing product quality, reduces maintenance cost, produces a low batch quantity at the earliest possible time, ensures the non-defective goods to the customers, reduce customers' complaints, reduce accidents, follow pollution control measures, favorable change in the attitude of the operator. Autonomous maintenance is a maintenance approach for routine maintenance tasks to keep the equipment in good condition and prevent breakdowns. Let us see the step-by-step improvement process and understand the equipment functions and safety risks. The 7 steps of autonomous maintenance: initial cleaning, initial inspection and registration, detect problem of the lives and restore the original state, start managing the line autonomously, create and perform temporary cleaning or lubrication, source of contamination and hard to reach areas, solve by cleaning, inspection and lubrication. Standard of cleaning and lubrication: develop tentative standards for cleaning, lubrication and inspection. General inspection: provide training on their equipment, products, materials and inspection skills. Autonomous inspection: develop a routine maintenance standard by operations. Standardize autonomous maintenance operation: standardize routine operation related to workplace management such as quality inspection of products, life cycle of jigs, tools, setup operation and safety. Autonomous management: autonomous team working. Tailstock: It is a sliding unit on the bedways of the lathe. It is mounted on the right-hand side of the lathe. It is made in two parts, namely the base and the body. The base bottom is machined accurately and has V grooves corresponding to the bedways. It can slide over the bed and can be clamped at any position on the bed by means of the clamping unit. The body of the tailstock is assembled to the base. Graduations are marked on the rear end of the base and a zero line is marked on the body. When both zero lines coincide, the axis of the tailstock is in line with the axis of headstock. The body and base are made from cast iron. The parts of a tailstock can be seen on screen. Purpose of the tailstock and functioning. To accommodate the dead center to support lengthy work to carry out lathe operations. To hold cutting tools like drill bits, reamers, drill chucks provided with taper shank. To turn external taper by offsetting the body of the tailstock with respect to the base. Functioning of a tailstock. By rotating the hand wheel, the barrel can be moved forward or backward. The barrel can be locked in any required position. The hollow end of the barrel at the front is provided with a Morse taper to accommodate the cutting tools with a taper shank. Graduations are sometimes marked on the barrel to indicate the movement of the barrel. With the help of the adjusting screws, the body can be moved over the base laterally and the amount of movement may be read approximately referring to the graduations marked. This arrangement is to offset the center of the tailstock as required for taper turning. Identifying defect in tailstock. Identify defect in a tailstock. Rotate the tailstock hand wheel for moving the spindle. Lock the spindle using the locking lever. Rotate the tailstock hand wheel and check the spindle movements and locking position. If the spindle is not locked properly, it will move. Hence, it is known as screw rod spindle lock is not working properly. Dismantle the spindle locking unit from the tailstock. Prepare the new screw rod instead of defective screw rod. Assemble the prepared screw rod instead of worn out screw rod. Check the tailstock performance and lock the spindle in the proper position.
In this video, we have learnt importance of maintenance for the overall effectiveness of equipment, inspection and identification of defects in tailstock. Thank you for watching.